Okie dokie. All right, so lesson 8 looks like this. Let me get everything going. Join up. All right, so let's go ahead and do screens off, phones away, headphones away. Turning around, paying attention. Excellent. Okay, so far we've used functions to make things easier. So we don't have to rewrite code. We can write a chunk of code one time. And since then, we've used the turtle functions that receive parameters as a way of making them more useful because they are customizable. You can send a value to the parameter for a specific amount of forward. And now we're going to get to write functions that receive parameters that we think are useful. Okay, we get to choose what the parameters are and what they do. Okay, so you could just hang out, whoever's clicking, just relax. All right, please do listen.
We're already seeing that some functions are defined parameters to make them more useful. For example, the original version of exactly 25 pixels. It doesn't give you a lot of options. A much more useful version of Blueform is one that accepts a parameter that allows you to specify exactly how far forward you're going to move. Up to this point, the functions we've written ourselves don't have any parameters, but the ability to write your own functions with parameters is both useful and helpful. So let's see how to do it. Here's an example. Look at this function that draws a square with sides that are 100 pixels long. If we wanted to make a function to draw a square with sides 50 pixels long, we'd have to make a new function that's almost identical to the first one, with the only difference being how far the turtle is moving each time. If we wanted even more options for the size of the square, every time we would need to declare a function. Yeah, that's not very good, but luckily there's a better. The solution to the problem is the ability to create a function that accepts any parameters. A parameter is a name value that is provided as an input to the function. We saw that our version of DrawSquare has a lot of code that was repeated. The turtle was executing the same basic behavior, just moving 5 different ways. It turns out that we can express this generalized behavior in our code as well. Here's a new version of DrawSquare. Here, we've made the size of the square a parameter of the function. Notice that the function heading declares that it needs an input. We've given a name to that input, and that name is size. Everywhere in the code where we need to use that value, we just enter the word size instead of a number. Writing a function with a parameter is very similar to writing a function without one. Just drag the function block that shows a parameter and drop it into the workspace. We add the name of our parameter inside the parentheses and the function call like this. Just as giving a meaningful and descriptive name to your function is important, so is deciding what to name a parameter. The name of a parameter should give some insight into what the value will be used for. In this case, we've chosen the name size to indicate that we accept the size of the square when calling the function. As a programmer, what you call your parameter is your decision. We can write the body of a function like this. The parameter size acts like a placeholder for that value. Wherever we want to use that value, we just refer to it as size instead of a number. Let's look at what happens when the function is called. Now, when a user calls DrawSquare, they call it with a value like this. We say the value of 63 bits passed to the parameter of the function. The parameter acts like a container with a name on it. Whatever value is passed into the function is stored in that container. Inside the body of the function, you will want to use the value stored in the parameter. To do so, you must refer to the value by its name. As the program is running, whenever the word size in this case is encountered, it's replaced by the value stored in that parameter. Adding a parameter to our DrawSquare allows us to generalize its functionality. In other words, our function is useful in an entire range of situations. as opposed to just being used for one instance. The result is a function that gives you much more flexibility and control without the need to create duplicated code. Once you've added a single parameter to your function, you might realize that there are multiple aspects of its functionality you'd like to generalize. For a square example, you might want to change the width or say the color of the line. To do this, you can simply add more parameters and separate them by comments. You can then use any of these parameter names in the body of your function. When calling your function, you'll need to include multiple values, one for each of the parameters, and each one separated by commas. Parameters are another example of how abstraction can be used to solve problems. When confronted with a group of related problems, we first work to identify patterns across all of them. In doing so, you might realize that using parameters will let you define a single function with general behavior that can solve any instance of a problem with one piece of code. This is a powerful skill that removes the need for creating duplicated code and leads to programs that are easier to read, write, and maintain.
All right. So if you were lost there a little bit, that's fine. We're going to go do a bunch of practice with it. So go ahead and load up lesson 8, bubble 3. And do yourself a favor, full screen. We're not going to be using very many other applications. Okay, so let's see here. Well, we'll just work through it and I'll give you all the stellar advice as it comes up. Okay, so generally a good idea in code, if you get somewhere and there's already some program code in there, hit run and see what happens. That will give you a good idea of where you're headed. Okay, so something's actually happening. So they've given us a call and a definition, and it doesn't quite work. So let's take a look at it. We are getting a move to and a function call of draw square twice, different locations. Each time the function is called, it's getting sent a value. Okay, this time 100, this time 25. And when it's called, it's receiving that number, whichever one it is at the time that it's called. Moving forward that amount, turn right, exactly 90. Move forward that amount, turn right, exactly. Move forward 33. We don't want to move forward 33. We want to move forward size. Okay, so the word, the parameter is in the definition, and it replaces wherever you want that to be used, whatever value you're passing to the function. And there you go. Okay, super easy. And bubble 4. Okay, so here we've been given some move tos and some function calls, draw a triangle, each of which already has a value to be sent as a parameter. Technically, when it's called, it's an argument, and when it's received, it's a parameter, but we'll just say parameter. In fact, I will remind you of the fact that it's technically called an argument probably every time. So we need to write out the program code that will draw a triangle and receive this parameter as it's moved forward. Okay, so we already have move to. Let's draw the triangle. How do we draw a triangle? Well, we draw a triangle with moving forward side length. That's how far we're going to move forward, is side length. Okay. When you're naming parameters, just like when you're naming functions or variables later on, it's important to use meaningful and descriptive names like was mentioned, but you need to avoid using reserved words, like syntax that the program already has saved to use. Like you can't name a function or variable or number. You can name it some version of that, but these words are reserved. There's also the possibility of being confused. Okay, like if we name this pixels or move forward and have the variable move forward receive a parameter called move forward, you're using things too many, like it's a little too on the nose with meaningful and descriptive. So we'll work on some tips for that I think are useful. But so which way we want? Turn left, and the supplementary angle for equilateral is 120, and we just need this twice more, thrice overall, and nothing happened. The reason nothing happened is we didn't put the pen down before we started the move forward, so we'll do a pen down there, see what happens. Good, and we need a pen up at the end of the function. And you'll see a lot of this as we do more advanced turtle things, where it's like pen up, move to, pen down, or if it's just within the function, pen down, do the business, and then pen up so that it can be used somewhere else. And so there we go. We've written a function that receives a parameter. In this case, the triangle side length. Bubble 5. And let's take a look. All right, so here we are given the definition for a function that draws a square of a certain length on one side and also receives a parameter for the thickness of the line, the pen width. Okay, so you can make parameters for anything. You can use them for anything. If you wanted to be weird, you could make the pen width size and the size border width, so long as the second number that you send when you call the when you call the function and send it to parameters, the second thing in parentheses, will get applied to the second word of the parameters. Okay, the first thing in the parentheses will get applied to the first word in the of the parameters and be used anywhere in there. Now, this would be a ridiculous thing to name the length that we use for the side as border width. I mean, it's not that ridiculous, but it would be confusing for sure. But yeah, so let's just stick with size being how far we move forward, and border width be how wide the pen is. Then when we call that, make sure that trash gets the trash can, please. Thank you. When we call the function, well, first we have to call the function's name, which is draw square, and we need to pass it two parameters, which, if you didn't see, there's now these arrows that expand to allow you to add more things. Let's zoom out. And we need to draw two squares. One of them is longer and narrow, the other one's shorter and wider, pen at least. So I don't know, just guessing. Let's say the first one is 100 pixels on a side, and again, guessing pen width of 8. And let's see what happens with that. Good. And then we need to draw square again. They've already given us the next move too, but this one we want shorter on a side. So let's try 50 pixels on each side and a pen width of 15 maybe. I think that's pretty good. Maybe a little squattier for the short one, but the idea is that we can receive two parameters. You can receive as many parameters as you want, so long as you keep track of the first number inside of these parentheses gets applied to this parameter, and wherever this word is used inside the definition will receive whatever number is sent. Okay. Okie dokie. Okay, so we need to do a draw triangle from scratch that we get to choose the names for the parameters. I'm going to throw some white space in here just to make it easier. Okay, and so we need a function definition. We already know the name that we want. It's called draw triangle, and we want to receive two parameters. And this is where we name the parameters. Okay, the words go with the definition. The numbers, if you're using a number, if the parameter is expecting a number, go with the call. So let's call the first one appears to be the side length, or I guess we can just use the word size, something that makes sense. Size and width are the two parameters that we want. Now we just need to write the code. We are starting with a pen up, so let's go ahead and do pen down, move forward. How far do we want to move forward? We want to move forward size. What's going on at the top of my screen? Oh, this thing is moving. Freaking me out. All right. And then we have another turn, which is 120. And we can do this twice more. See what happens. Nope. Again, we need pen up at the end of the function, and we need to send, we need to set pen width. We're receiving the parameter. When we call it, we're sending it a value, but we've not used it in the function. And I'm guessing, yeah, width is defined, but it's not called in your program. We're not using it. So we need to set the pen width. And how big do we want to set it? We want to set it to width. The name that we've decided will be the second value sent in parentheses. There we go. Okay, and the next one is a sort of interstitial check for understanding, but I'll give you a second to look at it without the answers provided. All right, so which of the following is not part of defining a function? Giving the function a name, identifying the parameters of the function, giving the parameters value, adding code to the body of the function. Anybody know? Go ahead and say it. What do you got? Yeah, you don't give the parameter value when you're defining the function. You're defining the function is just creating the useful tool. You give the parameters of value when you call the function. You're just identifying the parameters, naming it, and putting the code in there. All right, so you've seen me do this before, adding comments. Two main reasons for comments. One is writing notes to yourself or to others, but most likely to yourself in the future. And the other one is commenting out, where you can put 2 slashes at the beginning of any line of code and it will deactivate it. You can also do control slash. Slash just means forward slash. Control slash will comment out that code, deactivating it so that you can debug things. But here we are just using comments as notes to explain what's going on and make it easier. Okay, so bubble 9 and 9 through, I don't know, 13 or 14 are one project, one project that will carry over, meaning that whatever mistakes you make here are going to be with you for a while. And it also means when you get to later ones, you can't really come back to this one. I mean, you can come back to this bubble, but it will have your code, that whatever your most updated version of the code is. So be aware of that when you're doing version history, if you need to go back to something. Okay, so first one isn't really asking too much. It's basically making you find the comment block and drag it up to above, directly right above the draw starfish function call. And they want you to write the comment, draw all, I would say, of the starfish, even though they don't have of in there, it's a little casual. Okay, draw all the starfish. Now, we only have one call of draw starfish, and same for seagrass and fish, but eventually we will have more, and that's why it's draw all. Generally speaking, you won't use a comment anywhere except explaining what a function does, like at the definition. At the call, when you're calling, it's just calling is just using those tools that exist, where the comments above function definitions give you a lot of insight to what's going on in there. But it doesn't hurt to have it other places. Let's see how much it works. Okay. So we already have some stuff there. Just adding a comment is enough for bubble 9. Bubble 10. Okay, so next several challenges, work in one program, underwater scene. Each time for the next one you'll get instructions. Okay, read through the program, see what it actually does. Add function calls in the early lines of the program so that 2 fish, 2 starfish, and 2 pieces of seagrass appear somewhere in the scene. You don't need to provide values for the parameters at this stage. Oh, okay. But we will need to add a move to so that they don't draw on top of each other. So let's take a look at what we are given. Okay, we have 3 different functions going on. Draw fish, draw seagrass, and draw starfish, and a single call to each one. There is draw background, but that's just a dark blue dot that's big enough to cover. And each of these functions have a color and set a color, a pen width, and pen down at the beginning. And then they are hard-coded values, move forward a specific amount. Okay, none of these are receiving parameters. They are just exact amounts. We'd say hard-coded as opposed to using a variable or a parameter. And the only way we would be able to have different ones is by calling it twice, but we need a move to before we call it. Okay, so let's draw another starfish, and in order to draw it in another place, we need to add a move to and then call draw starfish. Okay, and where do we want to move it to? How about somewhere like here-ish? Let's just see what middle does. So middle X is 160 and middle Y is 225. And we'll see what happens. Okay, that's fine for now. We may want to rearrange it, but we know how it's written and we pretty much put it exactly where we want it. Okay, draw seagrass. Let's do the same thing and see what happens. Let's do a move to and call it call draw seagrass again. And let's just to sort of figure out what's going on, let's just go middle again, because we haven't really broken down how the function works. So we can just run and see what happens. All right, so we had a jump to middle and it draws up. So we definitely want our move to be somewhere at the bottom of the screen, somewhere y equals 450, which you can see here, the original move to is 50, 450. We want something 450. And let's see what 160, 450 gets us. Good, we're at the bottom, but we are also a tilt. And that's because when the first seagrass ends, it's pointed northeast. And when we move down here, it's still pointed that direction. because we didn't add a turn 2 before we started drawing. So let's add a turn 2 somewhere before draw seagrass, turn to 0. And I would argue that if you're going to do a turn 2 every time you call something, this should probably be in the function definition, and then you would never need to worry about it. A further abstraction. Okay, not bad. I'd like to scoot it a little bit left, so that would be lower x. So we're at 160 right now. How about what's going on here? I don't like that. All right, so this happens sometimes if you're messing around with the code while it's running and you try to go put your cursor there somewhere, it will like drag it out. So I can't like actually change. You can see how the cursor blinks to there. Just refresh the site, and that usually fixes it. Hasn't happened in a while, but it does happen from time to time. Okay, so I draw seagrass. Let's put it, like I said, 110, 450. There we go, beautiful. Okay, draw fish. Let's do it again. Well, I want the other fish up here-ish. So I'm actually going to move the second starfish down here. So let's go back to starfish. I want it a little bit closer to the right. So that's increasing the X, maybe 190, and a little bit lower. So that's increasing the Y. Let's see what 300 gets us. Okay, not bad. And we want to draw a second fish. So we need a move to and a draw fish. And let's put it over here. So we need to increase the X and decrease the Y. So how about 160, 50? Okay, a little overlap. Let's move it way more to the right. So instead of 160, maybe 200. There we go. Okay, we've got 2 of each, and they look intentional. Okay, they're drawn exactly the same because they are hard-coded for color and size. And they don't receive parameters, and we made 2 of them, and we're good to go. Okay, bubble 10 done. Bubble 11. Okay, so we want to add a parameter to the draw starfish function definition so that we can make starfish of different sizes. Okay, so we need to go down to draw starfish, the definition, and allow it to receive a parameter. We're going to name this parameter size because why not? And any place in the function that is going to affect its size, which is all of the move forward commands, instead of having a hard-coded value, we're going to put the word size. Copying and pasting is the order of the day. Okay, and now when we call it, we need to send it a number in order for it to work. And so the default was 60, or that's what was hard-coded. Let's push it in both directions. How about 30 for the first one and 90 for the second one, and see what happens? Okay, so you can tell that the way the starfish is made, the thickness of the pen width is such that if the forward length is long enough, it leaves a hole in the middle. So there's going to be a maximum size. And if you get too small, it gets kind of rounded because it's using the same pen width. Probably a good idea if we were doing this professionally, would make another parameter, or rather some sort of variable that would give you the pen width, make it a function, using it not in computer programming time, make it related or scaled to the size so that it would always have the same appearance, but just bigger. But we're not worried about that right now. We just want to make sure that we can send call functions that are, or excuse me, call draw starfish that are different sizes, maybe 40 and 80. Okay, and I think that's it for this bubble, which is 11. Yeah, that's it for 11. Okay, 12. We want to make the draw seagrass more useful by allowing it to receive a parameter that will change its size. Okay, if we go down and look at the definition for draw seagrass, the sizes of the arcs are all radius 100, which that's where it's getting its size. We want to make it so that it can receive a parameter that will make it different sizes depending on how we call it. So let's make a new parameter in draw seagrass, and let's name it size. You can use the same name in different functions because they work like local variables, and you can reuse names within that function definition. You can't reuse names if they are global. We'll talk about that later, but here, feel free to use size and everything if it's the most useful name. And size, the parameter that affects size is the second one of arc left. So instead of arcing left 30 degrees with a 100 pixel radius, it's going to be 30 degrees with a size pixel radius, whatever number ends up being sent. And that means when it's called up here, draw seagrass, we have to send it a number. The default was 100, so let's try it in both directions, like 70 and 140. There we go. So there's that. That's how that works. Okie dokie. So that's it for 12. 13, draw fish. Okay, let's change draw fish to receive a parameter that will affect its size. So we need to go down to the definition of draw fish. There we go. And how about let's call it size. This one's going to be a little tricky because we have pen width, dot size, and move forward a certain amount. Let's just change the move forwards to size and see what happens. So anywhere that it's moved forward, we'll put size. And when we call it up here, we need to send it a value. Was 30 before, so let's try 15 and 45 and see if we can break it. Okay, so clearly it looks weird, and that's because the dot, the size of the head, is proportional. So we can use whatever parameter, that parameter size, as the size of the dot for the body. Wonder what pen width if we change that. Let's see. Okay, that looks weird. How about let's change pen width to size also. There we go, scale. Okay, so this whatever number we send it is being used several places, which happens to work with this particular style of fish. Okay, all right, and let's see what's on bubble 14. Okay, let's make a drawing more interesting. Function draw fish, which allows you to set the color. Okay, so drawfish needs 4 parameters. Okay, size, which we already have red, green, and blue. Now, when we are naming, this is what I was talking about before. Okay, so we're going to change drawfish to receive 3 more parameters, so we can bump this out. And this, what will be the second parameter, we can make the red value that comes through, which will be used in the RGB triplet here. But I would hesitate against using the word red because it might be used somewhere else. And it's also not describing the fact that the parameter is the amount of red. So I would say probably something like redness. I mean, you could also just do the letter R, and you actually could just do red. It's fine in this case, but like I said, there's reserved words, and sometimes it can get in the way. You can get in the way of yourself. I'm gonna do redness. Redness. Is that how you spell it? Sure, why not? Nope, it's an N. And greenness and blueness. They're 2 N's. Wow, I'm having trouble today. Greenness. Does greenness have 2 N's in it? I don't know. Blueness. It actually doesn't really matter so long as you use it the same both places. So we're setting our pen RGB to whatever you used here, whether it's the word red, the letter R, whatever. The second one will be whatever is this value, is going to be the third value that comes through, because the first one is size. And whatever we do here, okay, and the order of the values that you send through, it doesn't have to be in red, green, blue order, but it makes sense because everything is going to be received in red, green, blue order. So there's no reason to mix things up. Okay, so now when we call draw fish, we need to send it 4 different values. The first one is going to be the number that we use, that we did a second ago, for the dot size and the move forward, that will still affect the size of the fish. The second one will be a number between 0 and 255 that we want to control how red that particular fish is. The third parameter will be a value between 0 and 255, which will be the amount of greenness in our pen RGB, and blue for the fourth parameter, which gets passed to technically the third parameter of pen RGB, but we are still sending it 4 parameters. And when we call draw fish, we need to send it 4 values. Okay, so let's make this one a red, purplish color. So let's go 255 in the red, 0 in the green, 100 in the blue. And you can use any combination of 0 to 255 for all 3. And later on, we will be using random number. Do we already have random number? We do have random number. Are we supposed to use it on this one? Nope, we're going to use random number shortly. Okay, so then for the other one, a bluish, low blue, maybe 50, 0, 200. Okay, so we're drawing 2 different fish, each with a different color. And there will always be those colors because we're not using random yet. Maybe dark blue was a bad thing for under the sea. How about, what is this going to be? There we go, teal color, lovely. Okay, so that's it for bubble 14. Okay, random input. So there are many times when you would want a random number in programming for something random to happen. And for real JavaScript programming, it is going to be, you're going to get a decimal. So random number 0 to 1 will give you a decimal between 0 and 1. In AppLab, random number 0 to 1 will give you a 0 or a 1 randomly. So it sort of has a built-in rounding function, functionality into it. That's fine. It simplifies things for new programmers such as yourselves. So if we want a random number to be an amount of redness, we would do random number 0 to 255 in the function call. Okay, so here, draw starfish, we want a random okay, so we need to add a randomness to all of our function calls. And so let's just go through this. Draw starfish, the only parameter we have for draw starfish is its size. So let's go ahead and throw a single random number in there. And anything that 40 was a little too small, or certainly on the smaller side, and 80 was sort of on the bigger side. So we need to keep our random number in a range, in a range that any one of the random numbers would work. So for the size of this particular starfish, maybe random number 45 to 65. And I mean, that's not a very dramatic range. Maybe 40 to 75. Okay. And we're going to do the same twice. And we will get different sizes, theoretically, because every time it's called, it's sending a different number. And I don't know. It doesn't have to be a dramatic range. Those are all very normal size. Okay, and seagrass, let's see, what is 60? Is 60 going to be too small? Maybe 50 would be on the low. Right now, I'm just trying to figure out what a good low end for the random number would be. Maybe 40. And I like this one, this taller one's 140, so I like that range. We'll go from 40 to 140 for both of these calls. Get rid of this. Okay. Then the seagrass will be different lengths each time. Excellent. Okay, and for draw fish, this one has a size of 45 and this one has a size of 15. I like that for the range. It's gonna get a little crowded here because we're gonna put a random number in for red, in for green, or in for red, for green, in for blue, and for the size. So you might run out of space on the right side. You can do Control minus to zoom out. That's a good keyboard shortcut. I'm pretty sure I showed before. Also Control scroll either direction if you have a mouse. That will give you some more space. You can switch to text mode. That lets you use the workspace like a regular text document. It doesn't jump around the way the blocks do. But either way, we need to put random number ranges in all 4 of these parameters. So this first parameter is the size range, which we like 15 to 45. The second number is our redness, so that needs to be between 0 and 255. And the same for green, 0 to 255. And the same for blue, and I'm already running out of space, 0 to 255. And we want to call draw fish with all this randomness happening twice. And there we go. We're getting fish of different size and different colors. And you can start to see, hopefully, how we can use random number in our program. Anywhere there's a number, we can make it a random one and give us a valid outcome. Every one of these move twos could be a random. The draw starfish doesn't really work with a random orientation. That kind of has to point up. But almost everything else that we're calling receives a value as a parameter, can be made to look or to have randomness in the output. Okay, and so let's take a look at the checks for understanding here. And go like this. Oh wait, 15. Yeah, we just did 15. 16. Okie dokie. So checks for understanding for this lesson. Okay, so consider the use of random number. Each answer describes the use and code shown. Example, which of the following is not a valid use for random number? Okay. Well, there is absolutely one. See if you can figure out which it is. I do not disagree with the answer on that one. Oh, 17. Ah, there's one more. Are these all checks for understanding? Okay, that makes more sense. Okay, bubble 17. Not just one. So now keep going, make the functions. Let's okay. Let's do we'll do one of these together. One of the things that I want. Let's give a random number range so that they show up in different locations. And let's do 3 of them for each. Okay, so think about where going through the starfish, we want the starfish to be on the bottom half of the screen, but we do want it to randomize. I'm really messing up this Zoom situation. Okay, so for draw starfish, let's put a random number for the X and a random number for the Y. And what is our valid range for X? Well, we could have it appear anywhere left to right, but we don't want it off the edge. So we're going to go, I don't know, 50 in from the left, which means the lowest X would be 50 and the highest X, 50 from the right, is 270. So a starfish will appear somewhere, anywhere across, a little bit in from both sides. And its random Y value, I don't want it in the top half. I'd like to keep it in the bottom half. So the lowest Y value will be halfway up, and the highest Y value would be 450, but we still want a little bit of space. So how about 425? Okay, and let's just call this exactly the same, but because of randomness, 3 times. There we go. And you could change the way there's like background and stuff like that to make them not overlap, but we are getting different locations and different sizes each time. Okay, and let's, should I do this for you? Why don't you go ahead and try to do the same for the other 2 entities, thinking about where, yes, we want seagrass random, but we only want certain random. Okay, the seagrass can't start anywhere. It has to start in a valid location with some randomness. And that's going to go in the move to, just like we did a move to random for the starfish. And then randomize the fish as well. Okay, the final checks for understandings for this, and you'll have time to come back to it at the end if you miss a thing. Okay, so we have another AP performance task prep question. Okay, more same abstraction question. Okay, below segment code from the under C program with a rectangle drawn around the portion that is identifying an abstraction. Imagine that you wrote this program composing an AP response, how this abstraction manages complexity. Okay, ignore the requirement of mathematical logic concepts because we're not there yet, but the key is about managing complexity. Okay, explain how this chunk of code manages complexity. Okay, it's essentially the only thing we've been talking about so far. Okay, two statements that are true about parameters. Yep, there are only two that are true there. And okay, abstraction is often used to focus on one general case and ignore specific instances of a problem. Given this meaning of the word, how are functions and parameters examples of abstraction? Okay, this can be one really good sentence. Doesn't have to be an entire paragraph. But you do need to answer the question. Okay. If you have any questions, let me know. We'll see how quickly we can get